All right, we're back. We're on page 106. Also, you might notice I just figured out how to zoom my webcam, so like I'm a little bit bigger in the picture now. I've been thinking about that for like a year, and just never really bothered to do anything about it. And then this morning I was like, you know what? To procrastinate, let's figure out how we can do that. And so I'm zoomed in a little more. I don't know. Maybe this is better. Maybe this is worse. Who knows? So we are talking about the ambiguous case of the law of sines. So the ambiguous case of the law of sines is angle side side, which I tend to think is a pain in the ass. And you know, your teacher might not like that. And I don't know, depending on YouTube, that may get blocked because I said that. But it's real pain in the neck. And it's easy to remember that it's ASS because it's a pain in the neck. So you could get no triangles, you could get one triangle, you could get two triangles when you were given an angle, the side opposite that angle, and another given side. These are the possibilities. So what I thought we would do is actually like solve one that is very clearly angle side side. And the reason it's very clearly that is we're going to work out what's going on. So we have two different triangles, and in these triangles, so the first thing I'm going to do is I'm going to drop an altitude here, so that I can break this up and just kind of like think about it, right? So here, if you look at it, you know, this is 3, and then this is 3. So I automatically know that angle A is 45, right? It's 45, 45, 90. So this is definitely 45. And over here, if I drop the altitude, so even though it's not the triangle that it's not an altitude that falls inside the triangle, but that doesn't matter, right? It's perpendicular to the opposite side or the line containing the opposite side. So it's the height. You can see that this is also going to be 3 and 3. And I don't know, I might need to erase some of this stuff that I'm drawing at some point. So angle A in this triangle is also 45. Now let's do the side opposite those angles, right? So here, what I'm going to look at to calculate, I want to find this side, which is here, right? So what I'm going to look at actually is I'm going to look at this, which is 2. I'm going to look at this, which is 3, and say that it must be the square root of 2 squared plus 3 squared. So it must be the square root of 13. So I guess I'll label it here. Now, what's happening over here? Well, if you look, I want this, right? So I guess I'll highlight that. I want this. And then maybe, should I start erasing some things? Sure, let's get rid of this because I don't really need it. I want to get rid of this also. Okay. And then over here, I'll get rid of this. And then if I zoom way in, it's a little easier to delete things without like messing everything up. Okay, so I want that. Well, even though it's in this triangle, there's no rule that says I can't use this triangle to figure it out. And this triangle is 2, 3. So it's actually radical 13 again. So this again is radical 13. So these triangles share an angle, and the side opposite that angle is the same. Now what we need is the other given side to be the same. And if that's the case, then this will be angle side side. So I'm looking for a color to highlight with. We need this side. We also need this side, and you can just visually see that they're the same. They're both in a 3, 3, 3, 3, 3 root 2. Here's 3, 3, 3 root 2. So they're both 3 root 2. So that is opposite angle C is 3 root 2. And so is that, oh, because it's the hypotenuse of a triangle, but not like this triangle, because these aren't right triangles. So I was like, that shorter? And of course it is. If you think back to the last video with our side that was like swinging, obviously it's shorter, because if it's not, no, it's longer. It's got to be longer. 4, not, oh gosh. You know, it's radical 36, right? Because you bring the 3 in is 9. Nope. Radical 18. Radical 18. Jeez, I'm like trying to de-rationalize. I don't know what I'm trying to do. Anyway, point is, in these triangles, we have angle, the side opposite the angle, and the other given side are the same in both cases. But you can see that the remaining information is not the same. So this is angle side side, and that would be the given information. Everything that we have here so far would be the given information, which maybe I should have color coded as I went. 45, and then I don't even know what color that was. Maybe this color? Yeah. This, and this, and then I don't know what color that is. Yeah. This and this. There's your angle side side. Now we got to find the missing stuff. So the missing stuff, what can we do? Well, you can actually just count for this, right? So B here is going to be 5. So 5. B over here is just 1. You can see it. So that's 1. And then we need some angles. So how can we get these angles? All right, so let's focus. Try to focus here. I would say that angle B is the hard angle to find. So I'm not actually going to find that. I'm going to indirectly find that. Angle C in this triangle, I can find because I know that this is 3. This is 2. So I can just do the inverse tangent of 3 halves. So C1 is tan inverse of 3 halves. Okay, and then I could find B1 by subtraction. Now the thing that I'm most interested in though is really in this triangle here. This is 2, this is 3. So this angle right here, if I find it, is going to be the inverse tangent of 3 halves, which means that this angle right here is a supplement of that. So angle C for this triangle is 180 minus tan inverse of 3 halves. And since it's 180 minus tan inverse, now look at that. What can I'm gonna highlight that. This and this are supplements. That is the key. When you were doing these problems, that's the key to solving the ambiguous case, is you're gonna end up using a lot of signs in general to find this angle, right? Which is really gonna be the only thing you can do. And then you're gonna use the supplement to find this angle. And once you know those two, you just kind of go for it, right? So I'm gonna take the easy way out here and say that this B1 is 180 minus A minus C1. And over here, I'm gonna say that B2 is 180 minus A minus C2. So I'm like kind of cheating, I guess, I don't know. But there you go. So that's angle side side. So we were given, so you're given that A is 45 degrees. Side A is radical 13. And then what else were we given? We were given angle C, nope, side C. Side C was 3 root 2, which I really struggled with. So you're given that information, 2 triangles. And that's what we figured out, right? So this is just an example where like we knew there were gonna be 2 triangles. The rest of this page is just kind of a summary of what's happening in the ambiguous case. So there are kind of 4 things, I guess, that can happen for an acute given angle, and then there's 2 that can happen for an obtuse. So let's just like roll through them. Here I would say the side opposite is less than the height. Therefore, 0 triangles. And you can see that it just kind of like swings through, and that's why that circle doesn't connect. Here, side opposite equals the height. And this is a miracle. You get 1 right triangle. Like what? That never happens in practice, but it could, I guess. That's where like you didn't recognize that it was just a right triangle to begin with. All right, here, this is the really interesting one. So this is the height is less than the side opposite is less than the other side. Right, so if that's, let me highlight this one to, okay, so the height is there. The height is less than the side opposite is here. And then the other side is here. So in that scenario, you are going to get two triangles. So that's the really exciting one. That's also the most work. Two triangles. We're going to use a lot of signs to solve them. Here we have the side opposite is just greater than the other side. Well, this is literally the first thing you should check. In that case, you get one triangle, and you just use a lot of signs, and you're kind of done. So let me highlight this just in case. So your other side there, and then your side opposite is there. I mean, I should have highlighted all the way through, but I didn't, and that's okay. Is it okay? I don't know. Got to tell myself that. All right. If the angle's obtuse, there's just two things that can happen. I don't really have a great story for that. Although I had like a story I was telling about pole vaulters at one point, or just, yeah, whatever. It's not the best, but you either get the side opposite is greater than the other side, in which case one triangle, use a lot of signs and solve it, or you get the side opposite. There's no height involved here. It's less than the other side. This one feels like someone lied to you. They're like, solve the triangle, but there are no triangles. Like, thanks. 0 triangles. Those are the best. It's really the best when somebody's like, solve this triangle, and you can just be like, there are no triangles. Yes. All right, so I'm gonna wrap this up here. I'll come back in the next one, probably do some problems. I don't really know. But anyway, I will see you there.